Okay, I think before starting the lecture, I would like to tell you that today many of you might be looking at the possibilities still, right? Whether you want to do a project or exam, right? A few things I should clarify you. The first thing is that on 8th March, right, the deadline, you need to submit the first PowerPoint. So now people who are going to do the project, so they have to anyway submit, right, in that problem. So what we are looking in that PPT is at least the literature review of that area, right? So you look at a couple of papers in that area or summarize it. So basically your job will be reading a lot of stuff, summarizing them in a nice PowerPoint presentation. In that PowerPoint presentation, we are expecting that you are going to use less text, more pictures, right? Now, that means how do you create pictures? Either you copy from here and there, which is your probably your usual practice, but then don't do that. So what I mean, in certain specific cases, with whenever you're using any image from anywhere, you need to see the, you know, the copyright warning or the terms and conditions TNC of how to use that image. So you need to give probably a proper reference and so on and so forth when you use the image in your PowerPoint, right? That sometime it is difficult to replicate. Try to replicate the image on your own with your own arts and creativity. That will anyway benefit you. Okay. If you cannot, for some reason, it is very complicated or something, so that's okay. I mean, then you need to look at the terms and conditions. Okay. Whether is it safe to use or you need to take some permission or whatever, do that actually, right? So if you want to seek some permission, there are procedures. Okay. Before using, this is a very common practice and I think many of you probably are not aware of it, how to use the images properly, right? Second, so what I am saying that in that PPT, you have to have minimum text, more pictures. That is number one. Number two, with proper citation of the pictures, and if you are creating yourself, then it's no problem anyway. Second thing, actually, uh, it should. Some people may say that how many slides, right? So the clear-cut answer is jiski jaisi shraddha. So if somebody is really needing 100 slides, it's okay. Somebody is reading 200 slides, that's fine. If you want to express yourself, right? And the best way to create these PPTs is what? You basically read all the literatures in that area, read couple of papers or whatever. Then close everything, take your laptop, go to the cafeteria, take a cup of coffee, and then just prepare the PPTs, right? Just do that, right? So that is the best way of creating it, right? You will see that in that case, there will be no copy paste in that case. Normally a habit is copy paste. You know why copy paste is very common? Because copy paste is Turing universal, that is also Turing universal. It's a machine, right? So you just copy paste, right? So basically what I'm saying that, so some people may say that should I take help of chat GPT, right? I don't know. Chat GPT can help you, right? By the way, there is a tool somebody has created to catch if something is done with chat GPT as well. Anyway, so that is one thing about PPT. So first thing, expectation from you that at least it will give a overview, literature overview of that area, right? And if in some cases it is possible that you are able to formulate a nice problem, that problem could be in the form of, some development, or it could be algorithmic work, which is perfectly fine and which is encouraged actually, because in that case, see, the leaders are always choosing algorithmic aspects, workers are always choosing development aspects, and there are some people who do both. They are also good. By the way, I always suggest that you should have 360-degree of everything. There should be algorithms, development. If you can do that, it's very good. What I heard over the last couple of days that many of you are having difficulty in reading the papers, right? Especially financial cryptography, you see there are so many things we don't know what to do because the reading habit is not there, which is, I mentioned to you earlier also, this habit we are losing. Many of young people, because you are born in the internet age, so you are losing this reading habits. At least over the weekend, you go and read general things. So very, very important than competitive coding. Okay. Because if you don't read, you don't know what is happening, right? you are just doing this, whatever other people are doing, let me do the same thing. If शेर आएगा तो उनको खाएगा तो हमको भी, अगर उनको नहीं खाया तो हम भी बच जाएंगे, right? So that attitude is always there, right? भेड़ चाल, right? So basically, don't go over the bhed chal thing, but I know it's a common human instinct, right? But you can probably do better if you find your own path. Okay. So this is number one. So basically, in the PPT, expectation is nice overview, and if there is a possibility of problem formulation, if you are able to do this, very good thing, right? But sometime, so if you want my help in any of the after, if you're not able to formulate a proper problem, you can come to me and I can tell you in that particular area what can be done, what can be done new, right? I get these things because I read still, I don't know. So if you read, you will also be able to do that thing, right? So that is very, very important thing. Second thing is that some people who are actually opting for exam, final exam, so they also have to submit the PPT, okay? But then in that case, it's just a overview. We are not looking for any problem formulation or something like that. At least a literature overview of some topic, right? So, so that something, because you see, in place of second midterm, we are having this activity, right? And the deadline is 8th March. So you have 7 days, very good time, holiday time, right? While playing Holi, you can actually do that, right? You can prepare PPT. So now, so any question about the PPT preparation? So some people are saying we have kept the theme of financial cryptography and they are finding it difficult to choose a topic. Can I do something else? Which is perfectly okay. I'm not, see, I just suggested a theme for this year. It's financial cryptography because there is a lot of low hanging fruits. So if you can pick up something from that area, it's very good. If you want to do something else, which is perfectly fine, I'm not saying to you that no, you cannot do this or you could not do that, right? It's entirely up to you. Now there are certain problems. So suppose you want to say that, for example, just now somebody came and said that I want to develop a encrypted chat, right? Now encrypted chat, you need to know. No, he's saying that we can use RSA crypto system for that. It doesn't work like that, right? Because what happens, each application has a different algorithm. And there are different, so you will realize, in fact, I will tell you, like now the topic that I'm going to cover is public key cryptography. And normally public key cryptography is used to encrypt the key, which is used in the private key cryptography. Like this symmetric key cryptography, right? So in the symmetric key cryptography, for example, either AES or DES, right? You encrypt the data using that algorithm. But the key, then you use RSA or any public key cryptography system. That is a trade-off. So basically, each application will have certain uh, choice, or options. Okay, if I want to build this application, there will be certain requirements in terms of the complexity. So based on the complexity of the problem, so what kind of algorithm is best and so on, you need to choose those things, right? So it's not like that. And I think many of you probably see, because while searching for what you do in searching the project, you look at the GitHub, right? Search in the GitHub, search in the YouTube, and maybe 1 or 2 or 3 pages on Google, not more than that, right? And some people may also ask ChatGPT to ask for the suggestion for the problem, right? See what kind of answers ChatGPT is giving you. But anyway, so don't depend too much on the tool. You will not get original idea unless you read yourself. Okay. So reading habit is very, very important. Now, when I say, okay, read yourself, so where to read? Now, if you look at in the cryptography, as I mentioned, there is an International Association for Cryptologic Research, right? That website I have shown to you in the first lecture or maybe second lecture. Go to that website, and there are many international conferences that are happening. So normally in cryptography, most of the literature comes in good quality conferences like Asia Crypt, Eurocrypt, Indocrypt, like that, right? So you basically look into those conferences, look at last 5 years, what has been done. So there could be papers in financial cryptography, there could be papers in other kind of cryptography, like homomorphic encryption is one very popular thing these days, right? So some people are, I think, interested in that. So, there are different communities also. There are some people have developed some platforms and so on, So what kind of work you can do, it all depends on what you want to do, okay? So basically, read those conferences, papers, explore, maybe you take a laptop or take a cup of coffee and just try to see, what happens when you're looking at a paper. Sometime you read something just like song, कोई गाना बहुत immediately अच्छा लगता है, right? कोई गाना लगता है नहीं, बार बार सुनने में अच्छा लगता है. Some paper you will say, oh no, this is for me. I think this looks interesting. Read the abstract, and if you find it interesting, you can go ahead and try to understand it more, right? So that is that habit is required. For that, you will use internet anyway, right? So go to some of these conferences proceedings and look at. Initially, you just look at the content, the program, what is there for the conference, what kind of papers work has been done, and then if something you find interesting by the title or looking at the abstract, you just read it, right? So that is very, very important for while picking up the problem, right? Today, I mean, only you have to decide about the either project or exam. I'm not asking you, it's not compulsory that you submit the project title as well or the area, right? If you have decided, it's fine, you can tell. If not, that's okay. You can do it by 8th March, right? You have enough time till now to figure it out. Any question about this project now? Now, the expected output in the final, it could be development of new algorithms, very good thing, top priority. If you can give up new algorithm or something, right? So that will be very good thing. Number two, some development, okay, of something, right? That is another output. Third could be at least, if nothing else, you are able to master one piece of cryptographic system deeply, right? Top to bottom. If you are able to do that much, I mean, it's enough for me, right? Okay, you have done something. So 3 outputs are possible, right? Either new algorithms, which could be, so there should be tangible result. When you are saying that new algorithms, that means you are able to publish something, right? In some of these conferences, right? If you are able to do something by this summer, maybe you can submit it to, normally this IndoCrypt conference happens in December, right? So there will be in the summer, there will be some submission deadline. You don't have to go anywhere. If you want to make career in cryptography, it's a very good chance that you just go and submit something in the IndoCrypt conference, right? If you are able to go up to that level. And if you say that, no, I don't want to do algorithms, I cannot do it. So maybe you want to do some development work, that's fine. So there should be tangible output in the form of some software or as an output, right? And third is a very nice literature review. That is the third output. Now, any question? Yes, you want to say something? Any question about the projects now? Hmm? So I think very good. So if you don't have any questions, so remember, whatever submissions you are going to do, you will just pass in through Turnitin, right? And the job is very easy, right? Normally, what I have done earlier, I'm telling you that if Turnitin says that this is 90% regularized, so that person will get how much marks? Out of 10? 1, right? 1 is the original contribution. Or if there is, 50%, the 50%, so you get, 5 out of 10. So very easy, right? I mean, it's the initial screening I'm saying, right? So you make sure that it's a 0%. And how you can make sure that it is 0%? There is only one way. Read everything, everywhere, close everything, take a laptop, go to the cafeteria, sit down and just use your brain to write something, right? So then I'm sure it will be 0%, right? And that habit you should have actually, okay? Okay, so now that's all about the project part. Now, so we need to start. So basically, as I mentioned in the last class, we were looking at hash functions, right? And then after that, one portion I have left right now is MAC, message authentication codes. But I think we will see if we can do it later on. So now I'm going to start the public key cryptography, which is asymmetric cryptography. As you know, that I think I told you probably earlier also, right? So by using different keys, so in the symmetric key, you have single key, right? And that basic idea that is there, if there is a corrupt postal system and you want to send something from one place to the other place using corrupt postal system to your friend, so what can you do? Suppose you lock it in a briefcase some document and you want to send it, but how will you send the key, right? Because there is a corrupt postal system. So any idea how do you do that? I think I asked you this question earlier, maybe in the discrete math class. No? How do you send something from one place to the other place through corrupt postal system? You can lock, if you lock it, it will be secure. But the key will remain with you. How will you send the key? So this is a big problem. Hmm? So then what we should do? Two locks. So okay. So then of course there is some overhead with this. So what you can do, so one person will lock it using his or her own key, send it, the other person put his own lock and send it back. So one way communication, there is only one lock. When the other person is sending, there are two locks. Still the system is locked. And then the first person who has sent, he or she will open his or her lock. Message is still intact in the briefcase and send it back. The briefcase is send it, you can send it back, and then the person can use the own lock to open the, you can use your own key to open the lock, right? So this way, there are three ways communication, right? Three communications in order to send a message securely, right? This is a very basic primitive idea, right? So basically, here we have used two keys, and right. So basically, in private key we have symmetrical single key is used, but in public key we will be using two different keys. So now here the idea of public key and private key will be used. So that is how the public key crypto system. And I think I have already given you the idea of RSA crypto system, right? So now I am going to look at some of the more details in terms of algorithms, the complexity of the algorithm, and so on, and how to attack RSA crypto system. Some attacks we are going to look at. Okay, so this is something interesting, and as you know, RSA crypto system will be broken completely if we have sufficient qubits quantum computer, right? And I think you might have seen recently some paper surfacing in the air that Chinese people have said that they have developed a quantum computer which can safely break the RSA crypto system easily. But I think still people say that probably it is difficult to implement or so on. And since we do not have very advanced, I think you know that there is the IBM has 400 qubits quantum computer right now, right? So probably another year or two, you will see more significant advances in terms of development of quantum computer. And I think people are saying maybe by 2030, we will be able to break the RSA crypto system, which we are currently using it actually, right? So as soon as that technology is available easily for everyone, it will be difficult to use the RSA crypto system. Okay, so that is one very popular thing, because we know that RSA crypto system is based on a difficult mathematical problem known as factoring an integer. Okay, so integer factorization is a difficult thing, and since it is difficult, we can build a computationally secure crypto system, right? So this is what is very important, right? So now, before going back again to the this RSA crypto system, I need to cover some basic beauty, which is mathematics, right? So some beautiful things I am going to recall. So by the way, the RSA crypto system normally, it was believed that so the key thing was Def and Hellman. They gave very nice. I mean, everybody should read this paper, Def and Hellman key exchange problem in 1976. It's a very interesting paper. This key business, how can be used to develop a crypto system, and finally, Rivest, Shamir, and Edelman developed this RSA crypto system. In fact, Edelman's job was to actually test the system. Okay, so he was mainly involved in trying to implement and see if you cannot break it. Okay, those kind of testing he was done a lot. So basically, so that's why it is the initials of Rivest, Shamir, and Edelman. By the way, Rivest was a professor at MIT. Edelman was in US Edelman is at right now at University of Southern California, and Shamir went back to Israel. And as you know, some of you might be knowing, Shamir is now also doing a lot of biology. And Edelman has invented DNA computing in 1994, right? So he has also done a lot of biology. So basically, there are certain interesting work by Edelman, even the DES, how you can attack DES using biology, you know. So biology and computer science are one of the same thing, or I would say a stronger statement that entire computer science or ICT is subset of biology. Okay. So if you want to have new ideas in computer science or ICT, you should look into biology. Anyway, all these people are now looking at biology. So they gave the RSA crypto system, which is based on factoring large integers. Okay. By the way, the same crypto system was known to UK government, and that too, in 1970. So this is the year when I was born, actually. So 70. It's very old. So I think almost 53 years old, right? So James Ellis, so there is a security agency at UK British government, so they have developed a system, but they've never disclosed. I think they disclosed it something around 1999 or so. Before that, nobody knows that they have already this system in place, right? So they were using for all this. This is a very secret thing. Cryptography is always, interesting to the governments, right? So if you are working on some secret things, that there are the government will be immediately involved. If you try to develop something new, even Indian government will be after you, right? So it's very important that it's very important area, right? By the way, the future is all about DNA cryptography, and when the intersection of biology and cryptography. So there are plenty of things that you can think of, and some of you can do even project there also if you are interested. Okay, so this is all about the basic little bit of history about public key crypto system. There is another one which is Elgamal crypto system. Abbas Elgamal is a famous professor. I mean, he has done a lot of work. And there are variants of it like elliptic curve crypto system. These are based on discrete lock problem. So I think what is discrete lock problem? If G is a group, how many of you have done course in algebra? Raise your hand. Oh, very few. If couple of people are having arguments and they are fighting, an ounce of algebra is sufficient. They will forget fighting, right? So this is a famous quote by ABS Halden, so an ounce of algebra is sufficient. Algebra is very beautiful thing, as you know, it's kind of generalization of number theory. But so basically, if there is a group, I will tell you it's an algebraic structure. Okay. So you know about field, right? I'm going to tell you some basic properties about group. So you know the algebraic structure field I told you. Field is a place where you can play with all four operations: addition, subtraction, multiplication, division, right? Okay. So in group, basically, there is only one set, non-repetitive set, and one binary operation, which has four properties. Okay. Closure property, associative property, existence of identity element, and existence of inverse element. These four properties are there. If any set has these four properties, it is known as group. And there are plenty of natural examples of group theory. Very powerful thing. And this was discovered when some people were trying to solve equations. So solving equations led to the development of group theory. It's a very interesting thing. Okay. So if G is a group and alpha is an element in the group, and if you raise alpha raised to power x, it will be some element beta, because alpha into alpha is a member of G again. Alpha into alpha is again member of G. So alpha raised to power x is also a member of G. So if alpha raised to power x is equal to, say, beta, belongs to G. So if beta is known to you, right, and x is known to you, how will you find alpha? It's like log, but this is discrete structure. So that's why it is known as discrete log. Okay, so solving this is a difficult problem. Okay, and that's why we have built elliptic curve crypto systems. For example, is one very popular one. Elgamal is another one. But the elliptic curve crypto system, what happens? There is a curve. So normally, curves, parabola, hyperbola. What else you know? Circle. all these curves have one very thing common. Can you tell me what is the very common thing about all these curves? Parabola, circle, hyperbola. Huh? I mean, that's not really interesting thing, but you can do parameterization for each of these curves. Parameterization is possible, right? For circle, you can do x equal to cos theta, y is equal to sin theta, or for parabola or hyperbola. All these curves. So all these curves where parameterization is possible is curves of genus 0. Genus is a measure, is a parameter, it measures the smoothness of the curve. Okay, these are genus 0. Genus 1 curves are known as elliptic curves. And if you look at the points, basically if you look at the curve over field, say real or complex, you will get infinite points. But if you go to the finite field with finite number of elements, you will get finite number of points. Okay, and so there is a very nice bound, Haswell bound, which tells you how many points will be there on an elliptic curve, which is a curve of genus 1. Okay, so basically these points forms a group. So if you take a point P on this elliptic curve, you add it, so P plus P is Q, or P plus P plus P. So if you add P m times, so discrete log problem becomes m times P is equal to Q, when P and Q are in G. Then again the same problem is there, right? So how will you find the, that unknown, right? So the discrete log problem is this is difficult to solve. So that's why people have built elliptic curve systems. They are widely used. And I think because they have short keys, so that's why they're widely used. I think in some of the electronic card systems, they were used initially, and now there are plenty of. In fact, in WhatsApp also they use one of the variant of elliptic curve crypto system in WhatsApp encryption, and plenty of applications. In fact, two of your seniors are working with us right now in fourth year on elliptic. They have obtained some good results in elliptic curve crypto system as well. And so a lot of things are there in that. So that is a difficult problem, and you can build a crypto system. Now, symmetric key cryptography. There is a symmetric key, common key between Alice and Bob, right? And so there is an encryption map EK or rule, and there is a decryption rule DK, right? So DK is equal to EK, or derived from it. So basically, let me show you. In public key, what happens? So EK is a public key or DK is a private key. There are two keys. EK is a public key and DK is a private key. Okay. So it is computationally infeasible to determine DK given EK. Okay. So that is something, the requirements of the system. Public key crypto systems are used to encrypt short keys used in symmetric key cryptography. As I mentioned, symmetric key cryptography such as DES or AES, okay, they can be used. So DES and AES are used for encrypting data. Okay, those ciphers are used for encrypting data, and the key is encrypted using public key crypto system. Okay, so this is the common trends. Okay, for data you use ciphers, AES, DES, whatever, and the key is used using public key. Okay, so this is the common difference. Okay, so there are hybrid crypto system as well. So there are a couple of steps. Alias first chooses the key L for symmetric key crypto system and compute y is equal to EL of x using key L. And then Alias encrypt L using Bob's public key EK Bob for public key crypto system. So you get Z is equal to EK Bob of L. This is key. Remember? Then ciphertext Y and encrypted key Z. So Z is the encryption of the key and Y is the ciphertext from the plain text X, right? Is transmitted to Bob. At the receiving end, Bob first decrypts Z because Z is the key, right? Encrypted key using his private key. Okay? And then so you get so basically L is nothing but DK Bob. So So these keys have this property that if you use the encrypted key and apply this private key of Bob, you will get actual key L. Okay. Now, step 2. Now you have L, right? So L can be used to decrypt Y. So you get the plain text. Got the idea? How this combination is used, right? To basically, so data is used, is encrypted through ciphers, AES or DES or whatever, right? The ciphers are used, and the key is encrypted using uh, public key crypto system, right? And so this is the common hybrid system, right? So public key crypto system never provides unconditional security. This is something I leave it for you, and I may ask you also in exam. Why? Public key crypto system never provides unconditional security. Okay, it's a very interesting thing to think. Okay, so we study computational security of public key crypto system. So okay, so so there are certain requirements. EK should be easy to compute. Inscription should be easy, and so computing the inverse should be hard. Encryption should be very easy, and the inverse of this should be very hard. Okay. Other than for anyone else other than Bob, person who is who want to actually get the information. So here is one such example. If P and Q are large prime numbers, you compute N, which is a product of two prime numbers. Okay. And now fix a integer B in Z plus. If F is a function from integer modulo N to integer modulo N, F of X is equal to X raised to power B modulo N. So this encryption rule, okay, and I think this condition is also there if GCD of B and phi N is, well, what is phi N, you remember? Euler-Torsion function, right? Phi of P is equal to P minus 1. So Euler-Torsion functions counts how many integers are there from 1 to N, which are, I mean, less than N and relatively prime to N, I mean, which are having GCD 1, right? So that number is phi of N. So for example, phi of 5 is 4, right? Because 5 is a prime number. So for any prime number, numbers are 1 because the GCD will always be 1. So P minus 1 numbers will be there, right? Or phi of 15 is how much? Phi of 15 is 8, right? So you know how to count, right? There is a formula also, phi of 15 is equal to phi of 2 into phi of 3. No, 5 into 3, right? So that is 4 into 2, which is 8. Okay, so that is a way to calculate. So this is RSA encryption function. Okay. Now I am going to, so this is our old friend integer modulo N, and I think again I am going to recall a few basic facts about integer modulo N or ring of integer modulo N. You remember Zn is a field if and only if N is a prime number, right? Otherwise it is not a field, it is a ring. What is a ring? So in the field you can do all the 4 operations: addition, subtraction, multiplication, division, and also that means normally every non-zero element has an inverse in a field, right? But in the case of ring, it is not true. For example, Z4, 2 has no inverse because 2 into 2 is equal to 0, right? Recall some of the basic things. So one element B in Zn has inverse if and only if GCD of B and N is 1. I think this is a result which I think we have covered in this class or the discrete math class. I don't remember. Maybe this class, I guess, right? So any element B in Zn will have inverse if and only if GCD of B and N is 1. For example, in Z4, 1 and 3 have inverse, right? But 2 doesn't have inverse because GCD of 2 and 4 is 2, which is not 1. Okay. So one element is invertible in Zn if and only if the GCD of B and N is 1. Okay. So as I mentioned, number of positive integers less than N and are relatively prime to N means GCD of those numbers to N is 1 is known as Euler-Torsion function phi of N. It's a beautiful function. and there are a lot of interesting generalizations of this function are available in number theory. And if you have some interest or passion for number theory, as you know, number theory is what? So you know that, right? That यथाशिखा मयूराणाम नागानाम मणियो यथा तो देवान शास्त्राणाम गणितम मूर्धानि स्थितम, right? So you know this fact. So no. So basically, in Vedang Jyotish, this shlok is there, which tells that mathematics is supreme among all literature, right? And then in mathematics, what is the most beautiful thing? So the mathematics is queen of science. That people say, right? Mathematics is the queen of science, and what is the crown of the queen? Is number theory. Okay, and in number theory, in fact, I will tell you there are certain gems on this thing which are known as quadratic residues. I'm going to talk about in a couple of minutes about quadratic residues as well. It's a very beautiful thing in number theory, a very, very powerful thing. Anyway, so if you look at Zn star, we are putting, normally we put a star means non-zero, but here we are putting Zn star means all those elements A reduced to modulo n such that GCD of A and n is 1. So basically I am counting how many elements are there which have GCD 1 from n. Okay, I mean not counting means I am collecting all of them in one set and calling them Zn star. So set of residues modulo n and relative prime to n basically. Okay, so the question is, if B is given, so one way of computing this is, if I want to find inverse of something, I can make this table. But it's a very crude way, right? I mean, just you make the table, multiplication table, addition table. Multiplication table is essentially if you want to find inverse of something. And from the table you can see, if A into B is equal to 1, then A is inverse of B, or B is inverse of A. You can check wherever in the table there is a 1, you know how to compute the inverse, right? But is there any efficient way of doing this? Can I compute inverse with some better algorithms? So yes, the answer is yes. We use extended equilibrium algorithm for doing that. EEA algorithm, extended equilibrium algorithm for computing the inverse of an element in Zn star. Okay, but now actually I invite you to think from some Indian perspective. Can you think of some better algorithm? Whatever I'm going to tell you, maybe yes, maybe no, I don't know. Take a cup of tea and sit down in the garden. You may be able to find something new. Okay, so let us see. The first one is equilibrium algorithm. You have been reading about this equilibrium algorithm, which is finding the GCD of A and B, right? And actually this algorithm can be used, this equilibrium algorithm can be used further in the form of extended equilibrium algorithm for computing the inverse. Okay, so I'm going to tell you some brief things which probably you know. Okay, so I have not, again, as I mentioned earlier, that statistical properties of Indian languages, I could not find much work. Similarly, if you think, I know that there's in the Indian literature there are some places finding GCD and other things are there. So if you can find something new, better algorithm, please look into the literature, right, and see. Anyway, so here A and B are the numbers, given numbers. I start with, I'm now forming sequence of numbers. I call them R0 is equal to A and R1 is equal to B. Okay, and then so R0. So then what I do? Basically, I do this division. So R0 can be written as for some Q1, right? Q1 is the quotient. Q1 times R1 plus R2 for some R2 which is remainder. So R2, so you know R2 lies between 0 and R1. Okay, this is the basic division thing we are doing, right? It is possible. Then once you done the first step, then I take whatever is left, which is R1, and do the same thing, repetition. So this time the quotient is Q2, right? And we can write the same way, we can keep on continuing. So we have here Qm minus 1 as a quotient, and finally there is no remainder left, so we are left Rm minus 1 is Qm times Rm. Okay, this is a possibility, right? When keep on doing. So basically GCD of R0 and R1 is same thing as GCD of, this is the observation between R1 and R2 and so on, between Rm minus 1 and Rm, and which is nothing but Rm basically. So basically this is the way we compute the GCD, that GCD of R0, R1 is same thing as GCD of A comma B, which is Rm. Okay, so we need to find this Rm. So what we are doing is continuously finding the quotient and finally, doing this algorithm. This is very common. I think you are familiar with it. You can write in the pseudocode in this form, right? Initialization with those A and B numbers, and then do this while loop, and then finally this Rm will gives you GCD of A and comma B, right? Okay. Now, so how we can use this idea, these Ris and Qis. Okay, I can extend it. Now I'm going to introduce some more sequence of numbers known as SIs and TIs. So define T0, T1, T2, Tm, and S0, S1, S2, Sm as, so Tj is 0 if j is equal to 0, so that means T0 is equal to 0, T1 is equal to 1, and T2 or T3 can be get from this expression. But what is Qj is the quotient that in that process that we saw, right? For j greater than or equal to 2, we obtain like this. Similarly, there are numbers Sj. So S1 is equal to, so S0 is equal to 1, S1 is equal to 0, and for higher orders, S3, S4, S5, we obtain it like this. These are the two expressions. By the way, when you do this, I mean, one would like to see why we, so what is the intuition about these numbers, why we are trying to do some calculations. Anyway, that is the important thing to think. Once we have this, there is this result we can obtain for each j between 0 and m. These Rj's are nothing but linear combinations of R0 and R1, where the linear combination values are Sj and Tj. I mean, kind of acting as linear combination coefficients, So Rj is as in that previous algorithm, okay. And the proof, I am not giving its on induction on j. I am skipping the proof. By induction on j, you can prove it actually. Okay, so I am leaving it as an exercise for you. So you assume that result is true for initial values, and then assume it for some j, and then prove it for the next j. Now I am going to describe what is known as extended equilibrium algorithm. Input is a comma b. This algorithm will compute r, s, and t such that r is a GCD of a and b, and also it will compute these integers s and t such that s times a plus c times b is equal to r. This is a very, very fundamental result. So if whenever there is a GCD of a n comma b is r, whenever GCD of a n comma b is r, you can find integers s and t such that s times a plus c times b is equal to r. So very, very fundamental result in number theory. Okay, and then next algorithm is going to do that actually. For that, we also use this corollary. Suppose, okay, we can finish this much. Suppose GCD of R0 comma R1 is 1, then the result says that the inverse of R1 modulo R0 is Tm. That means R1 into Tm is equal to 1 modulo R0, right? The product is 1. Proof is very simple. Suppose GCD of R0 R1 is 1. That means you have integers Sm and Tm such that you can write like this linear combination. You reduce whole thing by modulo R0. This term will go. You are left with Tm into R1 is equal to 1, right? So R1 and Tm are inverse of each other, right? So this is all. So next class, I am going to look at extended equilibrium algorithm for computing these things, and basically finding the inverse, how we can use it. And then there is a more efficient algorithm available for finding the inverse. Okay. So that's all. Now see you on Tuesday. Thanks.